Hi, welcome to DABLOCKS. In this video, we will learn about cryptography used in blockchain. What is cryptography? Types of cryptography, digital signature, and hashing. If you are new on the channel, my name is Himmat. Here we learn all fundamental concepts and practical development of blockchain technologies. So, if this is something helpful to you, then press the like button and subscribe to the channel. Also press the bell icon to get notified whenever we upload a new video. Let's get started. Cryptography. Is used for secure communication between two parties on the network that prevents the public from reading private messages. Let's suppose A want to send a message to B, where A is a sender and B is a receiver. A first encrypt that message and convert that to the ciphertext, which is non-readable format. Then the ciphertext transfer over the network, and once it reaches to the B, B convert that ciphertext back to the plain text and read a message. Here we have achieved encrypted message transmission from A to B. However, there are other problems on the network. First problem, confidentiality. Let us consider same example where A want to send a message to B, and while transmission, what if a hacker or any third person decrypt that message in between the network and read it? Then that message won't be confidential anymore. Second problem is authentication. A message should be created by a sender or authentic user only. Here there is no proof that this message is originally created by A. Third problem is integrity. A message should not be altered in between the network by a hacker or any third person. In this case, anyone can decrypt it, read it, or even modify a message and resend modified message to B. Fourth problem is non-repudiation. Sender should not deny of having sent a message. Here, there is no proof to validate this also. Now, before directly jumping to the solution of these problems, let us understand types of cryptography with the help of same example. First type, symmetric key cryptography. In this type, sender and receiver uses the same key to encrypt and decrypt the message. A converts the message to ciphertext using key 1, and at receiver's end, B decrypt the message using the same key, that is key 1. Problem with this cryptography is multiple key management. A used key 1 to send a message to B. What if A want to send a message to different receivers? For example, A to C, A to D, A to E. For each combination, A has to keep different keys, which is not feasible. So to overcome this, there is another type of cryptography. So second type is asymmetric key cryptography. In asymmetric key cryptography, we have public key and private key. Public key is accessible to all. Anyone can use others' public key, whereas private key is always with the owner. No one has access to others' private key. Here, A uses B's public key to encrypt the message, transfer that encrypted message over the network, and once received it, B decrypt that message using B's private key and read original message. With this approach, we have solved one of the network problem, that is confidentiality. We have used B's public key to encrypt the message so that no one else can decrypt it and read a message in between the network without having B's private key. Still, we have other network problems. In order to solve that, sender uses 2 times encryption. Sender first encrypt message using his own private key, then that encrypted message again encrypt using receiver's public key. And once receiver receives that message, encrypted message, it first decrypt using receiver's private key and then again decrypt using sender's public key and read the original message. Let's now check how we have solved other problems. Authentication. It ensures because message encrypted using sender's private key, which is authentic user. Second, non-repudiation. Since message encrypted using sender's private key and is only having his own private key, and sender cannot deny having send a message. Third, integrity. This achieved by encrypting message using receiver's public key. No one can read a message without B's private key, and only B is having his own private key. This is called the digital signature. Blockchain uses digital signature to overcome all network problems and provide a way to ensure every transaction is secure and by an authentic user. Let us understand another concept, hashing. Blockchain is a growing list of immutable records. Immutable means no participant in the network can change or modify a transaction once it's added to the block. Blockchain uses SHA-256, that is Secure Hash Algorithm 256, to achieve immutability. For any length of input data, it will generate fixed length of output value, which is called hash value. There are some hash properties. First, fixed length output. For any input length, hash function will generate fixed length output data. Second, same input data always maps to same hash. No matter how many times we create an hash, for the same input, it will generate the same hash value. Third, small change in data leads to change in hash. In this example, if we change small b to caps B, then entire hash will change. Fourth, hash to data conversion is not possible. Now, how blockchain achieves immutability using hashing, how hashing works in blockchain, how blockchain calculate hash. We will see everything in the next video, that is blockchain overview video, because we need to understand other blockchain concepts first. Thank you for watching. Please like and subscribe to the channel, and I will see you in the next video.